Hi, I'm Josh Murphy, and today I'm going to go into how nuclear power is really not that different than other forms of power. We're going to start out by explaining nuclear power. Nuclear power is getting power from the energy of an atom. This is called fission, and it is separating the atom, releasing the energy that is built into the atom in the form of heat. And from that heat, we generate steam, and through steam, turn a set of turbines and into a generator, which creates our electricity. We're going to start out by showing the first portion of a standard powerhouse. This happens to be a coal-burning powerhouse. For the most part, you feed in coal into a boiler. The coal is burnt. They have pipes that are going through the boiler. These pipes have water flowing through them. As the water is heated up in the form of the steam, it is transmitted through to the turbine. The turbine spins, the turbine is hooked to a generator, and the generator generates electricity. After the steam has turned the turbine, it will fall through the turbine and into what is called a water box. The water box is a giant condenser. This condenser is basically like a radiator on your car. This cools the water, and the same water is fed right back into your boiler to do the entire process over again. Beyond this, most power, electrical power, is generated in this format, in this country and in most other countries. Through coal burning, generating steam, and from there generate power. Now, I'm going to talk to you about the oldest form of reactor that we have in the United States. This is called a boiling water reactor, or a BWR. Boiling water reactor is much like the coal burning reactor that we looked at earlier. But instead of a coal fire to create the steam, you use the nuclear reaction. Water is dumped directly onto the nuclear fuel. The reaction causes heat, which pushes steam out to drive the turbines. There is several different parts of the reactor vessel that work in conjunction as safety-related features. But in all, the generator, the turbines, and the reactor are all fed in the same way as the coal burn. Water heated up turns to steam, turns the generator, and generates electricity. Afterwards, it falls through the water box, pumped right back into the reactor, and used again. Notice you only have two separate loops of water here. You have the first loop that generates your power, and you have the second loop that's generating your cooling. Let's go to what is now the most preferred form of generating nuclear power. One of the first things you notice is we have another component in this. This is a pressurized water reactor, or a PWR. This new component that we're talking about is called a steam generator. What we have is, instead of two loops here, we have three loops. We still have our cooling loop that we had before. Then we have our original pump, which is the water going into the reactor, generating steam. So then we have a steam generator. The steam generator is the water pours through the reactor, the steam generator, much like it does in a radiator. But it is used to heat another loop of water. This loop of water does not go through the reactor itself. So this loop of water is clean. It has not been exposed to any radiation. It has not been exposed to any radioactive decaying elements. And therefore, all the radiation and all the radioactive elements in a PWR are contained inside the containment structure itself. That is the reason it is the preferred structure, preferred reactor in this day and age. reason we go into all this is so many people believe that nuclear power is extremely different than any other form of nuclear or any other form of generation of electricity. But what we really do look at is there isn't much difference. Everything is all about generating steam and turning a turbine and creating electricity. Do we have any questions?
Sir, how many revolutions per minute does the turbine turn?
Each generator is different, but in the plant that I work at, Watts Bar, our average revolutions per minute on a generator is around 1,700 times per minute. Any other questions?
Yeah. You spoke briefly of using, as far as this type of plant goes, you spoke briefly of using radioactive materials. Do you believe that once science creates new and adds more radioactive elements to the periodic table, do you believe that you may use those instead?
Currently, the elements that are on the periodic table are all the natural elements that we have. If we were to move into other elements, all the new elements that we are finding are actually man-made elements. So therefore, it is more expensive to make the elements than it is to get power from the elements. So no, I don't think, unless as we explore into outer space, we discover new elements, I don't see us using newer elements to generate power, but that being the case, I think we'll continue to use the elements that we have, just in different ways. Thank you for coming and attending. I appreciate your attention. Good night.